Direct filling gold. Contents: introduction, history, properties of pure gold, indications, contraindications, classification, and manipulation of direct filling gold. Into the introduction. The quest has been on for the ideal restorative material, and it has been a challenge for the researchers and academicians in the field of restorative dentistry. And direct filling gold is the oldest filling material that is still used in restorative dentistry. So the quest has been on for the search of an ideal restorative material that can be used in the oral cavity has been on for decades, and it is a main challenge for the researchers and academicians. And one such restorative material which has stood the test of time is direct filling gold. The main advantages include excellent biological and mechanical properties, and pure gold can be cold welded and made to adhere to each other at room temperature. That is, when by the application of force, the gold pieces can be made to be cold welded, or it can be made to unite, and this is known as cold welding without the application of heat. And a unique property of gold is strain hardening. That is, the strength and hardness of the material is increased as it is cold worked or welded. And again, gold is very ductile and malleable and can be worked well against the walls of the cavity, creating excellent marginal adaptation of the restoration. Thus, a well done direct gold restoration can last one's lifetime in the properly selected cases. And what is the current status of gold foil? So in spite of all these favorable properties, the placement of gold foil restorations is at decline, both in the university-based practice and in private practice globally. In India, it is almost none. And the reasons mentioned by Gerald Stibbs include the lack of emphasis of direct gold restorations in dental curriculum and the lack of trained operators in the direct gold restorations. So the direct gold restoration is a technique-sensitive material and requires highly skilled operators for its placement. The properties of pure gold. Cohesiveness is the greatest among metals. It depends largely on purity, and the best gold for restoration purposes is 999 parts in 1000 parts pure gold. Coming to softness during manipulation, it again depends largely on the purity. Malleability, it is the highest among metals, and it can be reduced by beating to sheets of 1 by 250,000 of an inch in thickness. Ductility is against highest among metals, and 1 grain of pure gold can be pulled about nearly 500 feet long. It can be hardened in bulk form. That is, gold is about 1/3 as hard as diamond. And as mentioned before, it can be largely increased by hammering or rolling, that is gold, it is a form of working on it, or by annealing, which is a heat treatment. The Brinell hardness number is 48. Tensile strength, it is capable of holding a weight of 7 tons per square inch. It has minimum tendency to flow in the oral cavity. The coefficient of thermal expansion is 14.4, which is very near to that of enamel and is highly desirable. This is the noblest of all metals, that is, it is the most resistant to tarnish and corrosion. It is not soluble in sulfuric acid, nitric acid, or hydrochloric acid. Coming to effects of impurities on the mechanical properties, 0.2% of lead makes it very brittle, but the addition of calcium, palladium, and platinum improves its properties. In cold welding, that is, if two clean pieces of pure gold are pressed firmly together and a sufficient force is applied, they unite at their point of contact and the gold is welded together without the application of heat. This is a very important property. That is, simply with the application of pressure, two pieces of gold can be made to unite to each other. And that is known as cold welding. It has high thermal and electrical conductivity. The density is 19.3. So indications of gold restorations. Class 1, small caries lesions in pits and fissures. It is important to be noted that gold cannot be used in large or extensive caries lesions. Class 2, again minimal proximal caries in posterior teeth. Class 3, small caries defects in the anterior teeth only in the proximal surface, and very important, aesthetics is not affected. In class 5, in minimum caries in the cervical third, even non-caries lesions such as abrasion, erosion, and abstraction can be restored with gold. Class 6 lesions, that is incisal edges or cusp tip provided, there is no heavy occlusion load. And to repair small defects in gold cast restorations, also in retrograde root canal filling material after episectomy, because it is a very inert material. Contraindications, teeth with very large pulp chambers, severely periodontally weakened teeth with questionable prognosis, when economics is a limiting factor, and large caries lesion. in handicapped, elderly or very young patients who are unable to sit for the longer dental appointment required. The placement of gold restorations is very time consuming because it is highly technique sensitive. And so patients who cannot tolerate such long appointments should not be prescribed the dental gold restorations. And psychologically unsound patients who fear the malating process and where aesthetics is a prime requirement. Then again, inaccessible or poorly accessible areas where isolation is unobtainable, areas of undesirable occlusal stresses, and patients with a high caries index. Next is a classification of direct filling gold. According to Phillips, it is mainly divided into three. There is foiled gold foil or fibrous gold, electrolytic precipitate or crystalline gold, and powdered gold or encapsulated gold powder. That is gold foil, electrolytic precipitate, and powdered gold. The foil is again divided into sheet, rope, cylinders, laminated foil, and platinized foil. Sheet, rope, cylinders, laminated foil, and platinized foil. The sheet is again divided into cohesive and non-cohesive forms. Then the electrolytic precipitate or the crystalline gold is again of three types: matte gold, matte foil. Matte foil is nothing but matte gold plus gold foil, gold calcium alloy. And last is the powdered gold. So these are the types of direct filling gold: gold foil, matte gold, and powdered gold. And the last is the EZ gold. Gold foil. It is the oldest among all the forms described, and it was introduced by Robert Buffendale in 1795. So it has a standard size of 4 into 4 inch sheet. The gold foil is cut into 4 into 4 inch sheet, and the sheets are used to make books of sheets, and each sheet is separated by pages of thin paper. And this process makes the gold non-cohesive and can be made cohesive by annealing, which is a heat treatment. So the gold foil, it is available as 4 into 4 inch sheets, just made into books, separated by thin pieces of paper. Now we can see a 4 into 4 inch book of foil. It is marked for cutting and rolling into pellets. Here the corners of foil piece are tucked into the center. Here the foil is rolled into a complete pellet. And the gold foil is available in different numbers, and the number denotes the weight and thickness of the gold foil. Number 4 is a standard form, weighing 4 grains, 4 into 4 inch sheet, 0.51 millimeters thick. Number 3 is 3 grain, 0.38 millimeters thick. Number 2 is 2 grain, 0.25 millimeters thick. And gold foil box compartments are available, which are labeled to show the pellet size. So gold foil can be made into pellets of different sizes, and it can be placed in the gold foil box. Forms of gold foil. Again, plain gold foil is a product of the gold working procedure without any modifications. The advantage, ease of manipulation and workability. Disadvantage, it requires time for manipulation because of its softness and lack of mass. Next is corrugated gold foil. The concept of corrugated gold foil came into existence following the Chicago fire, that is in 1871. Here, a phenomenon was noticed, that is, when sheets of paper is placed between the gold foil and it is ignited, the gold becomes more cohesive. So this principle is used in the preparation of corrugated gold foil. It is manufactured by placing a thin leaf of paper between two sheets of gold foil, and after which the whole thing is ignited. And so as the paper leaves are burnt out, they shrivel and impart a corrugated shape to the gold foil. It is more cohesive than platinum gold foil. It is produced by sandwiching platinum foil between two leaves of gold foil. That is, platinum foil is placed between two leaves of gold foil. That is placed to increase the hardness of the finished restoration, and the percentage of platinum used is 15. Can be formed in two ways. That is, one sheet of platinum foil is placed between two gold foils, or layers of platinum and gold can be rolled over each other. Where is it used? It is used in areas of excessive stress, such as the incisal edge of anterior teeth, and also for the repair of crowns. Then next is laminated gold foil. It is made by combining 2 or 3 leaves of gold, and these 2 or 3 leaves of gold are made. It is made from different ingots, which have been cold worked in different directions. And so they can be resistant in different directions when combined together. It is available as preforms, but it can also be made by the dentist by placing number of sheets on top of another and then cutting the laminate into pieces of desired size. Now coming to types of preformed gold. There is sheets, cohesive gold, which is free of surface contaminants. Gold which is free of surface contaminants is called cohesive gold. Gases like oxygen can be absorbed on the surface of the gold, which will prevent the bonding of gold during compaction. Only if the gold surface is free of impurities, it can be welded at room temperature. And the advantages include free of surface contamination, increment of gold can cohere to one another, it is weldable in cold state, insoluble in oral fluid, it has perfect adaptation to cavity walls, it has more density, and pure cohesive gold restoration is strongest, densest, and hardest of all types. Semi-cohesive gold foil. Here a protective gas film like ammonia is deliberately adsorbed onto the surface of the gold by the manufacturer. It will minimize the adsorption of other less volatile substances. And it prevents the premature cohesion of gold during storage and distribution. And this thin volatile film of ammonia can be easily removed by heating. So here, in order to prevent the adsorption of less volatile substances, the manufacturer will place a protective gas like ammonia, that is, it is deliberately adsorbed onto the surface. And then it can be easily removed by annealing. Next is gold, non-cohesive gold. Non-volatile contaminants like iron, sulfur, or phosphorus is permanently deposited onto the surface, which cannot be driven away by heat. So the use is to build up the bulk of a direct gold restoration, which is rarely used these days. It is only occasionally used as a starting material in combination with cohesive gold, as they can be worked more easily. The disadvantages, it prevents the cohesion of gold into one another. It has less strength and hardness than non-cohesive forms, so it is no longer used. And the semi-cohesive form is now termed as non-cohesive form. Gold foil cylinder. Here, the gold foil is made into a cylinder using tapestry needles, number 22 size. That is, it is produced by rolling cut segments of number 4 foil into a desired width, usually 3.2, 4.8, and 6.4 millimeters. And that is done using a modified number 22 tapestry needle. Next is extra pliable gold foil. That is done to make the gold more cohesive. It is produced by wrapping a loosely formed regular gold rope with an extra sheet of gold foil. That is, it's a combination of gold rope and gold foil. And this can be cut into pellets. Next is gold foil pellet. Pellets of gold foil are generally rolled from 1/32, 1/64, or 1/128 sections, cut from a number 4 sheet foil. The bouquet foil is marked and cut into squares or rectangles. And each piece is placed on clean fingertips and the corners are tucked into the center, and then it is slightly rolled into the pellet form. Next is electrolytic precipitated gold. It consists of crystalline gold powder formed by electrolytic precipitation. That is, by a process of electrolytic precipitation, crystalline gold powder is formed. It is formed into shape by sintering, which is the heat treatment below the melting temperature of gold. What is sintering? It causes self-diffusion between the particles, and so the crystals actually grow together. That is, by electrolytic precipitation, crystalline gold powder is formed, and it is formed into shapes by sintering, that is, heating at a high temperature but below the melting point of gold, and this causes self-diffusion between particles and the crystals grow together. Types: matte gold, matte foil, and gold calcium alloy. Matte gold is a crystalline gold which is formed into strips. Matte foil is a ribbon of matte gold between two gold sheets, and gold calcium alloy is an alloy of gold with calcium. Now, matte gold is crystalline, electrolytically precipitated gold formed into strips or cones, and the advantage is the ease in building up the internal bulk of the restoration, because it can be more easily compacted into and adapted to the representative portions of the cavity, and it has rapid filling property. The disadvantages is large surface area, which does not permit easy welding into a solid mass, and a greater tendency for voids. Matte foil is a sandwich of electrolytic precipitated gold powder between sheets of gold foil. The sandwich is then sintered and cut into strips of differing widths. That is, the matte gold strip is sandwiched in between the foil. So the purpose of sandwiching was to eliminate the need to veneer the restoration of the layer of foil. So what are the advantages of this matte foil? Ease of placing gold in retention forms, and the reduction in placement time in larger preparations. And the disadvantages: There's a greater tendency for voice which was pits on the outer surface. Next is alloyed electrolytic precipitate. That is, it is alloyed with calcium. It's a newest form. It is known as Electra alloy RB. Here, 1% of calcium is allowed with gold. And the purpose is to produce stronger restorations by dispersion, strengthening. Advantages, it is easy to manipulate and higher density, so fills the preparation faster. But the disadvantages include inharmonious color and high conductivity. Powdered gold or spongy gold. It's also known as EZ gold. The particle size range is from 1 to 4 millimeters. That is, it is produced by atomization and chemically precipitated powders. And it is first mixed with a soft wax in order to form pellets. That is, powdered gold is produced by atomization or chemical precipitation. And this is mixed with soft wax to form pellets. And again, these pellets are wrapped in foil, number 2.5 or 3. So the resulting pellets will be cylindrical in shape and available in different sizes. The advantages, it contains approximately 10 times more gold than a pellet of gold foil of comparable size. And so prior to condensing, the matrix is burned away, so only the pure gold is available. Now, what are the advantages? Upon condensation, it spreads laterally from its point of impact. And it is important for the early stages of condensation. And here, the overlaying of gold foil is recommended. Next is golden. Here, it is a combination of powdered gold and gold foil. And the ratio is, so the ratio is 95% powder to 5% foil. It is provided in cohesive form. The advantage of this combination is that the envelope holds powdered particles during the condensation, making handling easier. Next is manipulation of direct filling gold. It consists of two main stages, that is heating or annealing or degassing. That is done to drive away the impurities. The next main step is condensation or compaction. So process of annealing or degassing or decontaminating, heat treatment or desorbing. That's different names. So desorption is heating long enough at a temperature that will remove the gases and in case of powdered gold, burn away the wax. So desorption is a process by which heat is applied in order to drive away the adsorbed impurities, or in case of powdered gold, to burn away the wax. The temperature used is 600 to 1300 degree Fahrenheit. The objective is to drive out the impurities of the surface, to keep the surface devoid of any other impurities until the complete cohesion occurs during building of the restoration. The desorption can be done by either piece method or bulk method. Piece method means a single piece is annealed at a time, which is usually done by the dental assistant. And the bulk method is degassing of several gold pellets at the same time. The methods of degassing. By an open alcohol flame, it consists of picking up each piece individually, heating it directly in the open flame, and placing it in the prepared cavity. Here, acetone-free alcohol is preferred, and the alcohol should be pure methanol or ethanol without any additives or colorants. And care should be taken that only the middle zone of the flame or the high energy reducing zone should be used. And each piece is held for 3 to 5 seconds before insertion with a gold foil carrier. The time is 3 to 5 seconds. Then the use of mica over a flame. Here a sheet of mica can be used over the flame, and the surface of mica is divided into several areas. This helps in indicating the time the pieces of gold were put into the mica. And maximum of 5 minutes is allowed. And while handling the pieces on the mica, it should not be handled with stainless steel wire points because it can contaminate the gold. Disadvantage, it is convenient for gold foil, but not for the other forms. So here is a mica tray mounted over the alcohol. Here we can see several pellets are placed in the mica, and it can be arranged out of the time that we placed. The maximum of 5 minutes can be used. Next is electric degassing, which is the most controlled and standardized way of decontaminating. The heating compartment is made of aluminium, and the surface of the heater is divided into small compartments, each accommodating a piece of direct gold. Again, maximum 5 minutes are allowed, and a temperature is 800 degree Fahrenheit. There is electrical annealer with several compartments where the pellets can be placed. So the next main step. The first step mentioned was annealing or heat treatment or degassing or desorbing. The next main step is condensation or compaction. It is a procedure which is used to harden the gold inside the preparation. Our objectives is to wedge the initial pieces between the dentinal walls. We can wedge the initial pieces, then weld the gold pieces together by complete cohesion and strain hardening. That is the objective of condensation. Then again, to adapt the gold materials into cavity walls, we can get a uniform compactness and also to develop the strength within the restoration. What are the modes of condensation? Includes hand instrument condensation, hand condenser and mallet, pneumatic condensation, electronic condensation. Gold condensers are of different shapes. Coming to modes of condensation in detail, the hand instrument condensation can be used as only first step in a two-step condensation because the energy which can be produced by this method is very less. And hand condenser and mallet, which is the oldest method of condensation. Pneumatic condensation, it uses compressed air and it is efficient but cannot be controlled. These are the mallet and the various types of condensers. There is round, parallelogram, foot, etc. Then electronic condensation is the most efficient and controlled way. Next is gold condensers, different types, round or bayonet, which is used in initial restoration phase. Next is Varney foot condensers for the cavo surface condensation, surface hardening and bulk buildup. So the initial is round, then for the cavo surface it is Varney foot condenser. Parallelogram and hatchet condensers for preliminary condensation create the bulk of the restoration. These are the parallelogram condensers. Now this is the working of a foot condenser, that is after the placement of the restoration, it is walked over the restoration. Helps in proper adaptation and also the sort of burnishing. Next is hand mallet and condenser. This is a picture of pneumatic condenser which uses compressed air. Now what are the procedural principles of condensation? The pellet is placed in the tooth, it is compacted to develop hardness and produce adaptation. So when gold is condensed, actually something called slip planes develop and that increases the hardness of the material. The line of force or angle of force, it is a direction of force exerted by the condenser. And the line of force must be directed at an angle of 45 degrees to the cavity walls as shown here. That is, it should bisect the line angles and trisect the point angles. The line of force at 45 degrees to the cavity wall and floor, it will bisect the line angle and trisect the point angle. And the force of condensation must be directed at 90 degrees to the previously condensed gold. So the force of condensation should be 90 degrees to the previously condensed portion. This will avoid shear components which can displace or loosen the already condensed piece of gold. And the minimal thickness of pellet should be used. Coming to principles of condensation, again see here it can bisect the line angle or trisect the point angles. Line of force should be 90 degrees to the previously condensed force. Previously placed gold restoration. Then this is stepping here. The face of the nib, is progressed in a stepwise manner, overlapping the previous step, so that more of compaction can be obtained. It moves in a linear direction and then in the opposite linear direction. Next is a process called bridging. That is when an improper building shelf is produced, a bridging occurs. That is when we place gold, if gold bulges form and it produces a convexity in the material, it will prevent the condenser from reaching the cavity wall and causing porosity. That is, if the gold bulges and produces a convexity in the material, it will prevent the condenser from reaching the cavity wall. Finally, porosity. And it prevents the proper lines of force from being applied and thus poor adaptation. And it can be prevented by uniform placement of the material and adequate condensation using the proper lines of force. So uniform placement and adequate condensation using proper lines of force. Next, stepping of the condenser. There's an overlapping by 1/4 of its diameter of the previous area of the condenser stroke, both in individual steps and in lines of steps. Stepping can be done in two ways. In rows parallel to the wall being approached, moving towards this wall, row by row, and wedging the last row beneath the already condensed gold and the wall, as shown in this. Moving towards the wall, row by row, and wedging the last row between the already condensed gold and the wall, or in rows perpendicular to the wall being approached. So always start at a point on one side and proceed in a straight line to another point on the opposite side, and then back to the original side on a different straight line. So this will ensure that the condenser has covered the entire surface of the piece of gold. So stepping is done in a controlled manner. That is, it is a overlapping of the previous structure by 1/4 of its diameter so that proper condensation can occur. And the advantages include, it ensures that each portion of the gold increment has been welded and forward. There won't be any voids, there will be maximum adaptation and denser restoration. So here, in each succeeding step, the nib overlaps the previous one by at least half of the nib face diameter. The condensation begins at position 1 and moves to the right, and then resumes at 2 and repeats movement to the right, 3, 4, 5, and so on. Next is pellet placement. Each pellet should be placed in the exact location. It should not be moved around, and the accurate placing is essential. And for that, the convenient points or starting points are placed in the cavity, which are refined retention forms. It is placed in the corner of the tooth preparation to accept the first pellet, and can be placed in the preparation to facilitate starting the tooth. It can be pyramidal or triangular to prevent slippage, and it is most useful in the proximal class 3 restoration. Here is a diagrammatic representation of the pellet placement. One pellet at a time is added. The pellet is fragmented. The corners are filled in first, and the edges of the cavity are covered as soon as possible to protect the enamel. It placed in bulk, then fragmented, corners are placed, and then the bulk is placed. Condensation of matte gold or matte foil is different. That is, condense by hand and spread thoroughly into the retention form first. The matte gold is actually spongy and thick and requires a rocking motion for adaptation. That is the most important point. It requires a rocking motion for adaptation. If the gold is too thick, the surface strain hardens. The surface will strain harden and prevents the condensation process from properly forcing the material against the tooth. Thus, if the layer is too thick, the matte gold must be broken up to prevent bridging and for obtaining proper adaptation and condensation. So that is the difference in matte gold or matte foil. It has to be placed in smaller increments, otherwise the surface will strain harden and prevent the placement of the subsequent restorations. And even though adaptation is difficult, the matte golds are easy to start in the cavity because they are spongy. So that is the main advantage of matte gold. It is spongy and hence it is easy to start with. Then steps for insertion of direct filling gold. The various steps to be considered should be done in a particular way. That is, this is 3-step buildup. The first step, there is a tie formation. As you can see here, there is a connecting of two opposing point angles or starting points, which is filled with gold with a transverse bar of gold. So the opposing point angles or starting points, which have been filled with gold, and it is connected by a transverse bar of gold. And that forms the foundation for the restoration. This is known as tie formation, connecting of two opposing point angles or starting points with the horizontal or transverse bar of gold. Next is banking of walls. It is a covering of each wall from its floor or the axial wall to the cavo surface margin with the direct gold. That is, from the floor to the cavo surface margin, the gold is placed. This is known as banking. A wall should be banked in such a way that it will not obstruct the tie formation or banking of other walls in the cavity. Next is shoulder formation. It is a connecting of two opposing walls with direct gold to complete the buildup. That is, the opposing walls are connected to complete the filling. Paving of the restoration. It is an individual covering of every area of cavo surface margin portion with excess cohesive gold foil. That is, after filling up the cavity, an extra gold foil is placed on top of the restoration, and a foot condenser is used for this purpose. Next is surface hardening. It is done to fulfill the rest of the condensation objectives, that is, strain harden the surface gold. Strain hardening is done. Burnishing, it should be done from the gold to the tooth surface. This is an important point, from the gold to the tooth surface. It enhances surface hardening. It adapts the restoration to the margins and eliminates voids. Next is margination. This is done with sharp instruments like knives and files. It moves from the gold surface to the tooth surface to eliminate excess material. Then burnishing, it follows the margination to close marginal discrepancies and to strain harden the surface. Again, contouring, this is done to create the proper anatomy of the restoration to coincide with that of the tooth. The proper anatomy is obtained by contouring. This again done with knives, files, or finishing burrs. Additional burnishing can be done. Finishing and polishing is done by using precipitated chalk or tin oxide powder. And then Final burnishing to ensure the closure of marginal voids and other surface disturbances. So to conclude, so we have talked about the steps: type formation, banking, and shoulder formation. The manipulation of gold foil, that is the lines of force at 45 degrees to the point angles. Then the stepping manner, the final contouring, the pavement, margination, burnishing, etc. So to conclude, properly done gold restorations can last a lifetime, but it requires a highly skilled professional. But again, its use is in decline, but many of its advantages remain unmatched. Thank you.